Okay, we're live. Welcome back to another episode of Learning Live with AWS and HashiCorp. This is the second episode in our series where we're going to build out a microservices architecture on AWS, Terraform, and a number of other services like ECS. But before we get into it, we should probably introduce ourselves for those who are just joining us for the first time. So let me introduce my wonderful streaming partner, Jenna.
Hi there. I'm Jenna Pederson. I'm a developer advocate at Amazon Web Services.
And my name is Cole Morrison, and I'm a developer advocate at HashiCorp. So, as a recap, what are we building out here, Jenna, at least in this first part?
Yeah, so should we talk about what we did last week?
Absolutely, yes.
Okay. So, well, actually, it wasn't last week. It was about 3 weeks ago. So, in our last episode, we kind of wanted to introduce the show and talk about kind of where we're going with this. And the long-term vision is that at the end of this series, you will walk away with a small microservices architecture that lives on Amazon ECS and that has a service mesh, HashiCorp's console product, that helps manage those containers and the service discovery of them. So in our first episode, we basically were just laying the foundation of what we're doing and the architecture that we're going to be aiming for, and then getting that first VPC set up. And that was there's a lot of work there. So there's a lot of tasks to get set up just to create a VPC. And so we got through that one. And then now we're going to take it another step further.
Yep, that is exactly it.
Yep.
Maybe I should show that little diagram here just as a visual.
Yeah.
It's a visual here.
Sure.
Yeah. Alrighty, let me pull that up here. And, oh, I didn't mean to rename it. Gosh. 1 second. Let me pull that up and then share my screen. Yes. So if I add this, we should be able to see this. So this is where we are headed, at least in the first section, as Jenna spoke about, and she pretty much talked about all of these different things. And like she said, we worked on the VPC, which is what's the correct word for this? Shown by the beautiful dotted lines there. And yeah, we'll be moving forward through to the public application load balancer, the client service, and a couple of other things, just so you can have a visual. Okay, so back to us here. Alrighty, so where does that put us here in things? So in addition to all of these things, I'm saying this more just for my own mental check mark, right? Is we're building these out, and we've got a handful of resources that we're going to be making today. And if at any point you've lost context as where we are, I highly recommend go and check out the link to our previous episode, which I can post in chat here. Let me go and grab that really quick. Bump. And let me find that here. Here we go. I'm just going to post this to chat for anyone who is interested, and we will put that in. And in addition to that, when we are recording this, so when we are finished, we will put it up on YouTube with you with all of the chapter markers, and you'll be able to navigate it. But before we get in any further, I know we do have some other stuff we're going to be doing today as well, and that is going to be a survey and then also some giveaways. Do you want to talk about the survey, Jenna? And I'll go ahead and show that on our thing here.
Yeah, I will. We'll share the survey about halfway through. But what that is all about is at AWS, everything we do is driven by our customers and what you want and what you need. And so we have the survey. It's like 2 questions. It's how did we do? How was the show? And an open-ended feedback question. And it could be, we'd love to have information on your feedback on how the show went, what you would like to see us cover or not cover, product feedback, if there's something like you're struggling with, or a new feature that you want of one of the products or services that we work with. We are here to take that back to the teams that build those. And so that's what the survey is all about. I will say the first 20 people that take the survey will get some AWS credits. So just a little bit of incentive to provide some constructive feedback for us. And I'll let you talk about the other giveaway.
Yeah, for sure. So the other thing we are going to be doing, as Jenna just mentioned, is a giveaway. And the way we're going to do this is we're not going to make you do anything crazy, but we do want to hear from you and what you think about it in a bit of more of a public manner. So I've just got here exactly how you can go about getting that giveaway. What you're going to do is you're going to make a post on Twitter or LinkedIn, one of the two. You're going to make sure you tag myself, Jenna, and the HashiCorp Live hashtag, and then just tell us about something that you learned from the stream, or maybe a cool idea that you got while watching the stream. And then at the end of the stream, after we're done, what we're going to do is we're going to select 10 people, and they're going to win a $50 gift code to the HashiCorp merchandise store. You can get stuff like this shirt here. And then we've got some other stuff like hoodies, mugs, laptop cases, socks, bandanas, a lot of different cool swag from our wonderful design team. So look forward to that. And yeah, just tag us on there and we will pull out random. That said, if we see a tweet or LinkedIn message that Jenna and I see and we're like, whew, now that's a good one, you know, we'll probably just give you one. So there's something to look forward to there. Okay.
So I have something for the audience. I want to make sure that this is an interactive session here. It's not just us talking at you. So if you are, tell us where you're tuning in from. I'd love to know like where around the world people are from and where you're hanging out today. And then as we go along, if you have questions or you're confused by something or we made a mistake and you need to help us out, please let us know in the chat, because that's going to make this entire stream a lot more fun for all of us. We sit in front of cameras quite a bit, and when there's no actual other person on the other end, it's really hard for us. So you all make this a lot more fun and engaging by helping us out in chat and asking your questions. So please do that.
Yeah, we've got a lot of good responses here. We've got San Diego, Seattle. We've got another person from Minnesota, Jenna.
Yeah.
Yeah. Someone in the United Kingdom tuning in, Cape Town, South Africa, California. It's from Finland. A couple from Toronto. We've got them all over the place. This is great. So thank you so much, y'all, for participating. Okay, well, that all said, we've got a few things we're going to be making, right? We're going to be making the cluster, the service itself, a load balancer, and then all the connecting pieces that go within. So if we're ready, we good to dive in here. Jenna, do you have any other thoughts before we get into it?
No, I mean, just so everyone knows, like our goal of the session today is we want you to walk away with one service that runs on ECS, and we're going to help you get that set up. Yeah, one containerized service.
Yes, one containerized service. Yes. Okay, so I'm going to have Jenna share her screen here. Are you ready for that, Jenna?
Yep, that looks good.
Alrighty, so I'm going to throw that on here, and hopefully everyone can see that just swell. So for the code part, again, if you want to follow along exactly, be sure to check out our first episode. And so because of that, we're gonna assume that you have all of those original prerequisites taken care of. So you've got an AWS account, the CLI installed for AWS, Terraform installed, et cetera, et cetera. And because we've been using infrastructure as code, and specifically Terraform, there's not a lot else we need to get set up here. So we do have our working repo that has already been shown, but let me just show it up here again if you want to follow along. And all you're going to do is clone that into a directory of any sort. And Jenna, would you show them maybe we can hop into your terminal, because what we're going to do now is stand everything back up again using our fun Terraform apply command. And that will take us right back to where we were.
Will you unshare my screen for a moment so I can fix the issue that's happening that we had last time?
I thought. Okay. Yeah. It actually looks. I can. Oh. Okay. I see it. Yeah. Let me pull that off here.
Yeah. Hang tight. I swear I tried to fix this before starting, but I did not. Apparently, did not do a very good job at that.
All good. But yeah, and so this time, the only thing I do want to say is, while we're going to be covering the ECS components, there are a couple things that we're going to not spend as much time on, just for time's sake, and that is around some of the stuff that you're probably already familiar with if you've worked with AWS before, and that's just like security groups and also the load balancers to an extent, not because they're not important, they're very important, but there's a lot of other materials out there. Ooh, Jenna, your screen just turned into an interesting pattern. Oh, okay, we lost her. Yes, the law of demos, Nicholas T. That is exactly what that is. Let me add her back here. Okay, welcome back. Here we go.
So the issue is with just so folks know what's going on. The issue is with our streaming platform that we use requires Chrome. I normally use Firefox. I opened up Chrome and they look so similar that I didn't really do anything about it, apparently. So let me get that screen shared again. And now we should be
all right.
Good to go.
Okay, that looks good.
Okay,
and the only other thing I want to say here is we are streaming to 3 different platforms: YouTube, LinkedIn, and Twitch. While we can respond very easily back to YouTube and Twitch, responding directly to LinkedIn is a little bit trickier. But the main reason I say that is that if we answer questions and you're like, well, I didn't see where that's coming from, it's probably because it's from one of the other platforms. Okay. So back to it, we're going to do a Terraform apply to show that, hey, we can begin right where we were, right, without having to do a bunch of other funky setup to get started. And this is going to show us all the resources it's going to go and create, which is just going to be the VPC. Oh, look at that. That was really fast. Nice.
Okay, so yeah, these are all the things we're creating.
Those are.
And I will confirm.
And while that does that, maybe do you want to just show your code base so we can check font size and also just walk them through the VPC file that we had made?
Yeah. So let me know if you need me to bump the font another level or so. So last time, most of the time we spent was in this file, the VPC file. Do you want me to walk through each thing, or what are you thinking?
Maybe just the main parts, just while we wait for just enough for as long as it takes for that thing to apply.
Yeah. So we learned about first of all, we learned how to go back and forth between our code and the Terraform documentation so that we can figure out which properties there are and what's required, that type of thing, how to name things. So we created a VPC resource here. We learned about using variables, which come out of this variables file. Yep. Sorry. Wanted to open both of those. So we learned about our variables and where those come from. We set up a public subnet and a private subnet so that we have access to the internet. And then we can also restrict access to the internet for the other subnet, the private one. Then we, what else is interesting? There's a bunch of different components or resources that go along with this. So you see route tables in here, the elastic IP address, internet gateway, NAT gateway, again, private routes. Oh, and then the route table association as well.
Yeah. You know, that's one of the interesting parts about when I got into infrastructure as code, both CloudFormation and Terraform, was like if you've been doing stuff through ClickOps, which was literally a word I'd never heard until I went to reInvent this past year.
Yep.
Is that there's when you're doing stuff through the console, it actually hides like a lot of these smaller things for you out of convenience. And then when you get in, you start saying, oh, there's all these smaller things happening in the background, like route table associations and the like. So it's a very neat way to get the inside view into how some of this stuff is created. So
yes, absolutely.
so
yeah, so I was going to mention, like, one of the other things we learned was how to use this count, because we needed to create multiple subnets, one for each availability zone. I think I'm using that correctly. And so we use that on a couple of these resources here. So that's a Terraform way of allowing us to create multiples of a resource and then vary some of the configuration for each iteration of it.
Yep, that we did, and that is that was when we started stepping into how you can do more than just define things one off. So, thank you, Jenna. How's our apply looking here?
Let's take a look. Yes, it looks like we are good to go.
Nice. Okay, yeah, and techie thought
Just
here.
make sure it's in the right place.
Yeah.
So yeah, we have our default VPC and then the one that we just created.
Yep, that we do. Okay, so just to give some context for just the 50,000 foot view, and I say that because we go into the details. There's tons of them. We made the network. This is the foundation of everything else we're going to build. Yeah. Today, we're making the cluster, the first service, and that first thing we are going to begin with is going to be the ECS cluster. So, are you ready to move on to that part, Jenna?
Yeah, let's do it. Do we want to talk a little bit about like what ECS is, and does everybody know what it is, and or should we like take
that would be a good first step. I like that.
Okay. So ECS is Amazon ECS. It stands for Elastic Container Service, and it is a way for us to manage containers. And it allows us to create a task definition, and then it allows us to run specific tasks based off of those definitions. They can be one-off tasks or they can be run within a service. And I think some of the kind of the difference there is a service is going to be, it's always going to, if it fails or for some reason shuts down, it's going to start itself back up automatically. So you don't have to worry about that. So it's kind of an always running thing. It's the kind of the same concept of a service that runs on maybe a virtual server. And then when it runs as a task, that is going to be more one-off type of things, like maybe like a batch job or a run job that you're running periodically. We are the ECS product has two ways of actually running containers, using Fargate, which is what we're going to use today, and that is going to be that allows us to do it on serverless infrastructure, and that means that we don't have to manage servers. We don't have to choose which instance type we want to use. It's all managed for us, and just based off of some parameters that we set. And then the alternative to that, which we aren't going to go into today, is also being able to run your containers on EC2 instances directly. And you might choose that if you need to have a little bit more control, or if you have a very, very large scale workload, it might make more sense to do it on EC2 instances. Yeah, so that's kind of like the high level.
Yeah.
What did I miss there? Is there something else that any other questions just related to the high level there?
I think just for to give my own self the solidification in my brain. I hate doing this, but by analogy is like, if you have no idea what ECS is at all, you probably know what Kubernetes is, right? Yeah, I mean, it's kind of hard not to. Well, ECS is like, is an alternative to that requires, like, I don't know, 100x less cognitive overload because it's managed, right? You're able, there's, Kubernetes is great, don't get me wrong, gives you a ton of control. It's got a huge community, and I love it to death. ECS though is going to take a lot of the operational overhead off of everything you're going to be doing. And in fact, we have a comment here that's pretty good. Less day two overhead, and that is absolutely correct. You just, what do you really want to do here? Are you looking to build out a full ops team that's going to manage every aspect of your cluster, or do you just want to, like, make a Docker image, make a container, put it up, and get to it and move on? I mean, it's that I'm oversimplifying it, but ECS for me has always been a nice alternative to that when I want to get stuff up and going. Also, I like this comment that Fargate is big.
I like that too. Yeah, and I think so. You mentioned Kubernetes, and I think, like, we need to be very intentional about how we are choosing the technology that is ultimately going to run our business. And so there isn't one that's better than the other. And so understanding what the options are and what your needs are is going to be really important as you get into making those decisions. So what we're showing you here today is the Fargate approach, the serverless approach, and it is going to make our life a lot easier because we don't have to do a whole bunch extra setup just to be able to show you how this works. So
yeah. And just to this kind of hops into a question we just saw, which was, philosophically, would you run ECS or Nomad workload? I want to say that Jenna's answer is kind of an answer to that. It's going to depend upon your situation. It's going to depend upon what it is that you're trying to accomplish, because they all have their strengths. They all have their less strengths. There are no weaknesses, right? So that's just my take on that. Yes, it depends here, right? That's such a good one.
Okay, I'm going to interrupt really quick. So we have some special people in the audience. Well, let me step back. You're all very special, but we have some other people here in the audience who are also special. And that I know Darko is here. Kunal is here from the AWS team. I think I saw Jackie and Banjo in there as well. I'm assuming, Cole, that you have some people on your end.
Yep. I saw Rosemary hop in here as well. So
excellent. And so all of these people are there to not just say hi to you, but to help get your questions answered. Have some friendly banter. I bet Kunal will tell you a dad joke. Just in case you would like to have some funny things going on. Earlier today, he said, oh gosh, now I gotta find it. The one that he just told me was, what do you call a skinny ghost?
What do you call that?
A Boolean.
Ha.
Yep.
Oh, nice.
Okay, should we get into it?
We should. I do have two things. One was just from Frank Chungus here. I'll try and show the full comment. Didn't care much for ECS until Fargate was available, like 5 to manage my instances. And that's exactly it. This is another case of what Jenna said. You want to use what works for you and for your particular situation. So it's a good example there. The other thing I wanted to do was, now that we have more people in here, is one more time I wanted to tell you all about our giveaway. So let me go ahead and just add that graphic back to the stream real quick. All you're going to do to get a $50 gift code to our HashiCorp merchandise stores, you're going to make a post on Twitter or LinkedIn, tag myself, Jenna, and the HashiCorp Live hashtag. Tell us something that you learned about in the stream, or a cool idea that you had from it, and 10 of the posters are going to receive a $50 gift code that you can use to get a shirt like this. Or let me see if I can pull down our store here. Can you see this on the stream? We've got some bandanas, other t-shirts, hoodies, backpacks, all sorts of other stuff. So I wanted to put that out there. Okay, but let's move on here. We've done a lot of the prerequisites. We know what ECS is now, and now we are ready to make the first thing. So why don't we go ahead and hop over into your code again, Jenna?
Okay.
Yeah, and let's answer the question, what is an ECS cluster?
Yes. So an ECS cluster is going to be a logical way for you to group your containers. Your containers, whether those are run as tasks or as services. So that's kind of the high level. It's going to be just a way for you to potentially scale them if you need to, that type of thing. So again, it's just a grouping of them.
Yeah, nice. I've always liked the by analogy things. The way I've always thought about ECS, an ECS cluster is it's like a fleet, right? A fleet of ships. Is any ship a fleet? No, it's not. But all together they make up one cohesive fleet that move together, that the fleet organizes and coordinates. So that's kind of the way I've always thought about it, because it's a very abstract concept, because you don't necessarily do anything directly to the cluster. You do it to the things in it, right? So, okay, so let's go ahead and make a new file for this, and we'll just call it ECS cluster, I suppose. And if you missed our episode from last time, we showed a workflow of how you can come up with how you should go about doing these things, drawing an analogy to the console pretty much the whole time. The docs open for the AWS provider, Jenna?
Okay. I do have those open.
Okay, yeah, perfect. Yep, and there's the cluster. And so again, these are always going to be structured by the example usage, the arguments you can pass to customize it, and the attributes it returns. Now, if we scroll down to the arguments, we will see the required ones, and there's actually only one required argument here, and that is name. That's all we need to do. I don't know if you wanted to touch on any of the other ones, Jenna, but for our purposes, the name is what we need.
I think I'm good right now.
Okay, cool. So
go ahead.
No, that's what did you have there?
No, nope, it's all good. Keep going.
Okay. All right. So let's go ahead and make that first resource here over in our code.
Okay.
Yeah, you can copy that if you want. I mean, we can modify it, or you can type it out by hand.
We're going to practice my typing skills.
And
make sure I remember things.
And we have that right there.
And we have some code completion.
Yeah.
Okay, so this is going to be AWS ECS Cluster.
Yep. And then as for the name, we'll just call it main, and that's how we're going to reference it. And then we just have that one argument, name. And we could just hard code this, but we've been following a flow of using that default tag that you set up. So
okay. And so we're going to use this.
Mm-hmm. And
then the name of the project, right?
Yeah. And to see exactly how to do that, if you just go to your VPC file, you could probably just copy paste exactly what you had there.
Okay, I'm going to have to do that if I don't remember now.
Yeah, all good.
Here we go. Just like this. But maybe without the VPC.
Yeah, there we go. And that is our cluster. So that is it. And this is what I said about how it's kind of like, it's like, what? Like, that's it? It's like, yeah, that's it. That's all we need here. So why don't we go ahead and do a Terraform apply and get that up so we can see it all up.
Okay.
So yeah. So this should be relatively quick. We did have a question about how would you recommend managing your TF state files for this kind of ECS project, store as a backend in S3. Well, S3 is always an option. I know a lot of teams will develop their own pipelines for managing Terraform. And any solution can take you far. My recommended approach is, of course, use Terraform Cloud for one reason. Not one reason, there's many reasons, but a big one is the fact that it allows you collaboratively work on the same project, which hopefully Jenna and I will be able to show here in some of the later episodes without worrying about that state getting messed up. Because when you just store it in a straight storage solution, there's no controls to really keep that in place. Anyhow, so it looks like we have an error here. So let's see.
So we created, and I remember we talked about this. Should we have a tag that has spaces and ampersands in it? And it worked for what we did last time, but it's not working for this. So
well, why don't we? What would you like to do here?
If we change this, so I think this is a good learning opportunity because I don't know how this is going to work. If we just change the default tag right now to something with dashes or whatever, will that update all of our currently tagged resources and create the cluster with this name?
It will. It will update. It will update everything that it can. But the surefire way is let's just go ahead and change it and do a plan, and it'll show us exactly what it is going to do.
Oh, I forgot about the plan. Okay.
There we go. Oh my gosh, ship it. Ship it.
Oh, I mean, I probably would have just done that, but not in a production environment. I would not have done that in a production environment. Okay.
And here we can scroll through and see everything that we're going to do. And very helpfully, we'll see a lot of these are just going to be updated in place, right? And that's really nice. Cool. So let's what we usually, when I do a plan, what I'm looking for is to make sure that nothing is being replaced. And if something is being replaced, that I'm absolutely okay with it being replaced.
And we would see that right here. It would say will be replaced or will be updated in place.
Yep. And instead of the yellow squiggles, we'd see red and green all over the place as well.
Okay.
So for most of these, it should be pretty seamless. And, if you're doing ClickOps right now, you'd be going through every single one of these things and doing it. So
we saved you some time.
Yeah.
Okay. So now I'm going to do Terraform apply.
Yeah. Yep. And we can see right at the end there, right? 1 to add, 10 to change, 0 to destroy. That's what we want to do.
Oh, yeah, exactly.
Yeah. Perfect. And in the meantime, we had what cybersecurity tools would you recommend for Terraform? And you mentioning TFSec, and TFSec is great. In our recent Hashi Talks 2022, we actually had a talk about TFSec and using that. There's a number. It's kind of hard to cover the whole list, but TFSec is definitely something that'll help you catch a lot of different things and control a lot of different guardrails. And I believe one of your colleagues, Jenna, Oscar Medina, he's going to be doing a stream next week about using those type of controls so that you can keep those in place. So look forward to that.
Do you know where that stream is?
That will be right here, actually. It'll be right on our YouTube channel with Sarah McDonald, who's the product manager for the CDK for Terraform team. So
excellent.
Yeah. So this is going to go and change all of those things and make that cluster. And while we're waiting on that,
it's done.
Oh, nice, perfect.
I told it to do it.
Nice. All right. Well, would you like to pull that up in the console just so we can see that it's and this isn't necessary. Obviously, at a certain point, you will believe that it is doing what it's saying it's doing. But at least in the first iterations, it's just that habit force of just, I got to go see that something's up. And there we go. Yep. It is all up and good to go. All right. So that moves us on to our next resource, unless you had anything else on the cluster, Jenna.
I'm good. I feel like 3 lines of code and pretty darn.
Yeah.
I mean, I know we have some more to write, but
yeah. So the next thing, and this is just something that's kind of interesting about development. When you go to make these things, where do you start? Where do you end? And the odd part is when you're doing infrastructure as code, you can kind of do it however you want. So we're trying to take an approach of like how just sort of organically you would build it up. And probably the first thing you would do even before the cluster, but the cluster first makes sense, is defining your task. And defining your task through a task definition is basically, we're just trying to figure out how we get our containers on ECS. So did you want to tell us about what an ECS task definition is, Jenna?
Yeah. So it's a task definition is going to be, it's ultimately a text file. I think it's normally in JSON. We're going to use Terraform to essentially create that text file. And what it's going to do is you can think of it as like a blueprint for your application. So it's going to let you configure some of the parameters for your operating system, which containers to use, which port your app needs to have open, any data volumes that need to be mounted. I think you can do up to 10 containers per task definition. So you want to like group them according to like related containers if you need to have more than that.
Yeah. And going back to my analogy here, the cluster is like the fleet that all the ships belong to, right?
Mm-hmm.
Well, I would usually say an EC2 instance would be a ship, and then it would hold these different containers, right? But the task definition I've always thought of exactly what Jenna said, a blueprint, an order form for some set of containers that need to be created. And what do they need, right? So cool. All right, so let's make this next file for our task definitions. This is not going to make the task. This is just the, as Jenna said, the blueprint for the task. And we can go and we can take a look at the docs if you'd like, so we can see all the different things that need to be there. Yeah, there we go.
I assume this is the one we want, the AWS ECS task definition.
Yeah. Now, this is always interesting to me from when I got into ECS, and really for a lot of different cloud services you get into in general, is there are a lot of different options and parameters that you can specify. So which ones do we focus on, right? And we have a required list here, but even though we have required and optional, it's not always as it can still be a little bit ambiguous. So instead of trying to walk through each and every one of them, we know the exact ones that we need to specify. Unless you wanted to touch on any of them specifically, Jenna.
I don't think so.
Okay, cool. Well, there are 5 we are going to need here before anything. And then there's also going to be a 6th one, which is a long one where we're going to define our containers and their needs. But why don't we handle those basic ones first, right?
Okay.
So the first one we're going to do is just the family, right? And that is, well, actually, we should probably define the resource first. And yep, there we go, the task definition. And this is going to be our client. And so this first thing is we need to give a name to the task definition. And that is not going to be named. It's actually going to be, yep, family right there. Okay. And for the name, we could hard code it, but what do you suggest? Do we hard code it? Or do you
we're going to do the same thing we did the last time.
Nice.
Which, hang on. Something like this.
Oh, nice.
Did I do
nice.
Do we want to do the dash after, or because we were doing like dash VPC, dash subnet. Do we need to differentiate these?
Yeah, I think so, because we'll make some more task definitions later. So probably good to yep. And looking through those docs, let me pull them up as well. Although you've got them up. There, if you look through the name, the family is really one of the only, the name and the container definitions are the only required ones. However, there is a catch here, and that is if we choose to go with the launch type of Fargate, right? Because when we do the launch type of Fargate, we do have to specify so how much CPU and memory is there. So yeah, there it is. Requires compatibilities. That's what we're looking for.
Oh, right. I was looking for Fargate. I forgot it's
different.
I don't even see it now.
I think it's up in the first column or the first little section right there.
Oh, there we go.
Under, okay. Yeah, there we go. So that's going to be our next attribute we add in.
Okay.
And this is just saying, hey, this requires the launch type is going to be Fargate. And we actually need it to be in square brackets, because you can also say that this task is valid for both Fargate and EC2. But in our cases, we're going to just, just going to do a Fargate for now. Now, when that is the case, and this is where I like to draw the analogy of the console. If you're making a Fargate task, what does it usually ask you next? Well, it usually asks you for the memory and the CPU. And that's what we actually need here as well, right?
Okay.
So if we look over at the docs, I think that'll give us some more insight here into that.
Memory.
There's memory. Yep, and there it tells us that it's required if the requires compatibilities Fargate is field is there, and then the same should be true for CPU. Yep, perfect.
Okay. So
we'll just put those in.
And these are numbers.
Yep. And what this needs, well, it's a fake service, so it really doesn't need much at all. But I don't know what I'm not sure what the minimums are for Fargate. I'm pretty sure that it translates to 256 though for CPU and 512 for memory.
Okay.
Yeah. Over 9,000. No, that would be a lot. Yeah. And then the final thing that we need to do outside of container definitions is specify the networking mode, right? And so this is the Docker networking mode, and there's all the Docker networking modes. But let's go take a look at that in the docs one more time. And that is right in this first section here. Well, I thought it was. It should be network mode. Just network mode. It's right under memory, right under memory. Yep, there it is. Yep. And we're going to go with the AWS VPC one, right? Because we want to use the AWS VPC.
Yeah, we created that, so we should probably use it.
Yep, we did. And then before we go into the next container definitions, again, like when you're looking, I just want to show this workflow one more time. When you're looking at this the first time, it's like, how did you all decide to do these attributes first? Would you mind going back over to the AWS console, Jenna?
Yeah.
And then, oh, sorry, the AWS console, not
yeah. Oh, I'm sorry.
Oh, you're good.
Yep.
And then just over to task definitions. Yep, and then just creating a new one, and then doing Fargate. We're not going to actually save this, but I just want them to see.
Yeah.
Like, this is how we came up with it. Task definition name, that's equivalent to family, right? So we would have done that. The networking mode we filled in. Some of these we didn't touch because we didn't need them.
Okay.
Right, and then there's the IAM role for task execution, which is also something we didn't need. But if you wanted to, say, hook it up to CloudWatch logs, you would want to add that there. Yep. And then if we scroll down more, we'll see task size, memory, and CPU, and then finally container definitions. The reason I like the console here again is because, well, it gives us what are these defaults and these required ones that I should concern myself with. And all of the other attributes or arguments that you can specify that we saw in the Terraform docs, well, those are supporting things that you can customize if you need them. But all right, cool. So any thoughts or commentary on that before we move on to the longer piece?
No, I just was noticing this little tooltip here. When I specified the memory and CPU in our Terraform file, I just put a straight up number in megabytes. But here it's showing, obviously, it shows gigabytes. And it's just saying you can specify it in either. It just depends on how you do that. So,
yeah. Nice. And so we've got two questions I want to address here. The first one is from a LinkedIn user, because LinkedIn's being LinkedIn. And it's CPU settings here reserving minimum resource for the container, but it can use more than that by default up to the Fargate or EC2 instance limit.
I do not have an answer for that. I'm not sure.
Yeah. So I'm not sure how it works on Fargate. I actually don't know how this works on Fargate. I do know on EC2 though that depending upon what you said, it's a hard or soft limit. Where a soft limit being where it tries to keep it to it, but it can go over if it needs to. Whereas in a hard limit being something that you can't go beyond. But perhaps one of our amazing AWS colleagues can add some context to that. I know that we could probably easily find that in the docs, but
yeah, that's actually a good idea. Let me see if I can find it while we're chatting.
Yeah, cool.
Well, okay, let's keep going. I will keep looking, or someone on chat will keep looking and try and get that question answered.
Yeah, that works. So, and then we did have another question from Darko, actually, which is, would this application now auto scale? That is an interesting question with Fargate. Would it? Would it just, if we overload it, will it just make a new Fargate task?
So I think that depends on how we have it configured. If we set, and there are limits somewhere. Maybe not on the task definition, but within our cluster.
Yep. And that is the thing for the task def. And right now, nothing will auto scale simply because all we're doing is defining the task. Right. We actually haven't said how we're going to launch it, how we're going to keep it alive. But I believe that Fargate should just continue adding. Well, at least that's my what I believe happens in context of it. And we'll see that when we get to a service. But yes.
Okay.
So for sake of time, though, we should probably move on to the container definitions.
Okay.
And this is where we are going to define our containers. So we have two things here.
In this resource, or is that a separate resource?
That is within this resource. It is yet another argument. So there we go, container definitions. Now, before we just go ahead and start making stuff, we actually need to make use of another internal function. You know, we don't have to do it like this, but I think it's easy to keep it all in place. So I'm going to just send you the link real quick, Jenna, and pull that up at your convenience. I'm going to go.
Where did you send it to me?
Just in Slack. And then I'll also going to just post it there. And yes, we've had quite a few people chime in around where we get the scaling from Fargate, right? And it's going to be within the service. It's when we specify the counts, the max, and those different settings there. So we had Frunk chime in with the answer. We also had a Techie Thought chime in with an answer. So thank you all so much. So JSON in code here, all this is going to do is make it so we can write in HCL and it will turn it into JSON, because for container definitions with task definitions, they do need to be written in JSON. And okay. Darko has answered the CPU question here. The limits to the CPU are the limits. It is the hard limit. And he also pointed to the docs here as well, so that anyone who wants to look at those more in depth has that there. Okay, so there's a lot of stuff here, but in essence, all we need to do, let's go back over to the code. Yeah.
I'm going to actually use this JSON encode here.
Yep, we're going to write JSON encode, open up parentheses, and then open up square brackets. And within here, each curly brace that we open up is going to be one of our container definitions. So why don't we open up a pair of curly braces?
Okay.
All right. And so within here, we're going to define our first container. And this is going to be the client. And we're going to be using Nick Jackson's wonderful fake service repository. And that's going to allow us to create a fake service. So let's go ahead and begin with what those things are. You're not going to really find these in the Terraform docs because at this point, we've crossed over back into ECS AWS land. So in terms of getting those, do you by chance have the ECS docs up? Actually, you know what? I can just grab Darko's thing here and open that up. ECS Task Definition, Container Definitions. Because it's another one of these things where there are a number of different things that you need to look at. However, what the required ones, there's going to be far less. I can just send you the link, Jenna, if you need. Oh, it looks like you've got it. So we just want to click on container definitions over there in the right sidebar. Sorry, on the right sidebar.
Oh, sorry.
Oh yeah, you're good. Yeah, there we go. So these are what we're going to be defining here. Now, instead of making you all go through the labor of sorting through these and figuring out, because you do get a lot of control over what it is that you want to do, we already know the exact ones that you need, right? So why not wait for time? We'll just go ahead and get to those. So the first thing we're going to need is the name, as we see here, and that's just the name of the container and how it's going to be referenced both within this task definition itself and by the service, the ECS service, when we go to hook up a load balancer to it. So for this, we don't need to really add the tags to it, because this is within a different task definition. For example, you could call another thing client because it's only for that. So let's just call it client.
Okay.
Yeah. And the next required parameter is going to be image. And that's going to be the Docker image we're going to be using. And I believe you have the reference to the Docker image we're using, Jenna?
Yep.
There we go. That's our fake service. And let me look that up and here we go. I'll put a link to that in the chat so we can so people can see it there. And that brings us next to CPU that this container requires. Now, this is interesting, and it's documented, and I find it very something neat, which is that you can specify the CPU of 0, and when you do that, it'll actually just take up a proportional amount of CPU. This is going to be really helpful if you've got multiple containers defined in here. But since we have only one, this works regardless of what we do.
If we had 4 containers in here, we might put 25. It's like a percentage.
No, it's actually the amount that it requires.
Okay.
However, when you post 0, and let's say we had another container that wanted 128, well, this one will then just work to take up whatever it needs or just whatever it needs, instead of trying to take up all of it or a defined amount.
Okay.
So whether or not that trick is a good thing to do, I mean, it's in the docs, and I've always kind of done it for better or worse, and it's always worked out well. So that brings us to our next thing, which is the essential argument, which is literally just essential. And this is just going to be, this container is required, right, for this task definition to be considered healthy and valid. If this container goes down, any other containers in here don't matter, right? Because when your service or your task is looking at it, it is looking to this one to see if it's good. Okay. So that brings us to port mappings. And that is going to be how we map to the ports on the container. And we'll just open up. Yep, there we go. Connection.
And stuff in there.
I think this part. If you want to walk us through it, Jenna, I think you've
so this is we are connecting our host port to a container port, and it is just making sure that from the outside we can actually get at what container or what port that container is going to run on, or that it exposes.
Yep, that's exactly it. I think we need curly braces though before we open it up.
Oh, we do.
Yep. And so it's like, well, how do you know it's container port 90?
Oh, it's not 90.
Or 9090. Like we know because in the fake service image that we're using, it requires, it listens by default on port 9090. So the container is already listening for it. So that's why we're saying, hey, this is where this maps to. The host port, something interesting is when you're on Fargate, you need to specify the exact port. However, if you were doing this on EC2, you don't. You just need to specify the ephemeral port range, or I believe nothing at all, and it'll just pick that up. Since you will, if you have multiple containers that need 9090 and they're all on one EC2 instance, that wouldn't work. But yes. So, and then our protocol you've got there is TCP. Perfect. So the last thing we need here, and then we'll answer some questions. I see a few have popped up, is just some environment variables. And these are just going to purely be in there to configure fake service. There's nothing special about these except that fake service looks for these to do what they need to do. So we're just going to define a few. So that it really likes that connection autocomplete, doesn't it?
Oh, what is happening? Something is very weird going on. Like I have like, like even my tabs are like so big.
Yeah.
It's not normally like this, I promise.
Yeah.
I did just get a new computer, so that could be.
Oh, nice.
It could be just I haven't configured everything yet.
Ah, the fun first journey of a new computer.
Yeah.
Telling it not to use a zillion spaces per tab.
Right. Okay, so we're doing name, message, and upstream URIs. That's what fake service is requiring. Is that the deal?
Yeah, we can actually leave the upstream URIs out for now because there won't be any.
Okay.
But we'll come back to those. So what these two environment variables are doing is they're just telling fake service, hey, my fake service name should be client, and the message I should return when someone pings me is hello from the client. Right. So simple enough. Okay. So we've got a couple questions in the chat. Here, the first one is, do those two parameters, memory and CPU, determine the cost for using ECS? When cost is a factor, what do I need to be mindful of?
That is a good question. I'm just trying to look at, it's going to depend on, depend on whether you're using Fargate or EC2. In the case of Fargate, it looks like it's it's priced per CPU per hour and gigabyte per hour. We're gonna drop this into chat just so that you can see a little bit more detail. But yes, those would be things that you'd want to be paying attention to. Yeah.
Yeah. I mean, I think that was it.
Yeah. I'm not going to get too far into it because there's more to it than just what I can say in a short period of time. But I do want to make sure you have the answer or have the reference to that. So nice. I will add this into. Nice. I don't have a way to put it into the LinkedIn chat, but maybe someone else could help me with that.
Yeah, I've got it on screen for us here.
Excellent.
And then also Darko added a nice little comment there, which is just limit your CPUs and memory on Fargate to avoid triple dollar signs. Yeah. And then the other question we had was a more general question about Terraform, which is if you need to pass variables like passwords, which services better, Vault versus Secrets Manager. So here's my general answer to that. When it comes to Vault versus Secrets Manager, if you are all in on AWS and you just need secrets and you just want to get it done, Secrets Manager is probably going to do what you need it to. Vault is a lot more beyond Secrets Manager, so it's going to give you a lot more in its toolbox that it does. It can also do that for you. But again, like we've said, it depends based on what it is that you want. Okay, so there is our container, our task definitions in the blueprint for the container that we want to put up and get live. And this is going to take us to the ECS service now. So are you good to move on to there?
Sure.
Cool. What are you thinking about the survey? Is it time yet, or do you want to?
I thank you for that reminder. I think it is a great time to put up the survey. So we'll drop a link in chat. But you can also use this handy dandy QR code to take the survey. First of all, we very much value your constructive feedback on how to make this a better live stream, both each episode, but also in the longer term. We value your feedback on the topics that we're covering, and as well as any feedback that you have on products, both for the AWS or the HashiCorp side. We're both developer advocates. We advocate for you, and we can bring that feedback back to our teams if there's anything that is happening or going on or that you're struggling with, or new features that you want. So keep that in mind as you're filling that out. Also keep in mind that the first 20 people who fill it out will get some AWS credit codes. I can't remember the denomination. It's probably like $25. But yes, please help us with the survey.
Nice. Okay, so there we go. Definitely take a look at that survey. I believe it's pretty short, and free credits are always good, right? Okay, so stepping into the ECS service. What is an ECS service, Jenna?
Okay, so a service, remember how we talked a little bit before about how a task definition is the blueprint for your application. So a service is going to be, so when you start up a task, it can run either as a service, which is, I'm going to say in a second, or can run independently one-off as a task. And so if it's a task, it's going to be something that, starts up and shuts down, and then you go along your way. If it's a service and something happens to that particular container, the service itself is going to make sure that the container gets recreated and it gets replaced so that you are meeting the requirements of your application. So in case something happens, you want to make sure that it's always available. So it's just it's another way of making sure that you have a higher availability and reliability in your application. Let's see what else. Yeah, so that's high level. That's what that is.
Okay.
Just making
So
sure
it
I
sounds
covered
like-
all the things from my notes. Looks like I did.
So it sounds like tasks are one-off, services are for long-lived, and for a number of other things, including
Yep.
high availability. And I know that's like if you want to load balance containers behind something, right? That's the services, how you're going to get that done too, right?
Yep, exactly.
Alrighty, well, let's get to it. So why don't we go ahead and make a new file over here.
Okay.
And as following our current scheme, looks like ECS Services would probably be a good name. Yep. And then we can, there's actually not too much here, but I do want to just say when we are making this service, we're going to have to play the Wikipedia article whole game where we're going to start defining this, but we're going to have to pause. We're going to go have to make some other stuff and then come back and do it. And it's just how the nature of infrastructure development. So why don't we pull up?
And I just want to make sure people understand kind of what we're saying here. When you say the Wikipedia approach, there are these dependencies. The different resources have different dependencies on each other. And so when we create one, we have to, before we can finish filling out the attributes or arguments, I might have that term wrong. For one, we have to go create the other one, and then we reference them.
That's exactly it. That's perfect.
Okay.
Yeah. Okay. So docs, we can, would you like to, we can pull those up. So at this point, we'll just show them But we, just for sake of time, we'll go ahead and just start coding them. As always, there's a good example usage of everything we need. And on that list, that little example, that's showing most of what we need to do. We're going to need the name, cluster, the task definition, desired count, and launch type, which isn't actually shown on here. So we're going to define that. That's the basics about the service. We're also going to need to give it a load balancer. So that's something we'll need to do. And then we're also going to need to define a security group for it and where to put this service in our VPC, which is also something not shown there. So why don't we head back over to the code unless you wanted to explore those docs more?
I'm good with keeping going.
All righty. So would you like to walk us through these first, well, first off, making the resource and then these first arguments that we need for it?
Sure.
All right.
So we're going to start with that. Oh, I didn't do it right. There we go. This is going to be that AWS ECS
Service.
Service.
Yep. There we go.
It wasn't coming up. I didn't like that.
Yeah. Sometimes it gets confused.
And this service is going to be for our client service that we just created, our client that we just created. We're going to give it a name again. And let's do, we're going to use that. I think it's called default tags.
Yeah, I think that's what you named it. Yep.
I do need to have this in double quotes.
Nice.
I've got a name.
Let's add that client suffix.
You want that on there again? Okay.
Just because we'll have more services later.
Sure. Yeah, that's true.
Yeah.
And then we need to tell it, see what is happening with this. 4 spaces for our tabs today. Then we need to tell it what cluster. So we just created the cluster, so we need to reference the one we created, which we can do by
the resource type, and then our. Go ahead.
Nope. Then we call it main. And then I suspect that we need to do something else here.
Yep. So we've got the reference to it, and now we need to reference its attributes. So, yeah, and there we go. It's pulled up the 2 attributes that you can reference from.
You can do either one then?
We actually need the ARN for this one.
Okay.
Yeah.
So our documentation would have said the ARN.
Yeah. We can go look at it again, but again, we covered attributes pretty in depth in the previous one. So just know that every resource in Terraform, you have the arguments, how you can customize it, and the attributes that you can pull from it after you've declared it.
Okay.
All right.
And then we need to tell it which task definition to use. So we did just create one of those.
That we did.
And we're going to do basically the same thing. We're going to say that resource, and then this also takes an ARN.
Yep, it does.
But not that.
Yeah, there we go. Yeah.
Okay. And so well, there was a question earlier about like how many does it spin up? Like does it auto, I think the question was from Darko, and does it automatically auto scale? And this is where we're saying like how many, this is where we're gonna say how many of these should we create, how many services. In this case, we're just gonna do one.
However, if we wanted to do like 3 or 4, well, 3 or 4 would launch, and ultimately our load balancer would go to those different 3 or 4. Yeah.
Okay.
And then I think we got one more thing.
That thing is launch type. And we're saying that we're using Fargate.
Nice. Very nice.
Okay. So this is where we have to, I think this is where we have to go and do some more stuff before we can finish creating.
Yeah. Let's go ahead and scaffold out a little bit of this. Yeah, so the new thing, can we pull up that service documentation you had again?
This one?
Yeah, here we go. Yeah, there we go. Oh, no, sorry, the Terraform one.
Oh, sure.
that you just had. Yeah, there we go.
Oh, yeah.
So in here, something we didn't really touch on too much are nested blocks. So nested blocks are just blocks with more attributes. It's a little bit more of a cleaner grouping. In this case, the one we're going to need to work on is the load balancer, right? That's what we're going to do next, because we want to connect the load balancer to the tasks sitting, well, the containers sitting behind that service. So let's go ahead and define most of that out. And if you want to just copy that, that is more than fine with me. We can just drop
we all
that in.
like copy paste.
Yeah, copy paste is good, right? So the target group are, and this is what we're going to have to go and make. We don't have this yet, so you can like comment it out or something if you want. But we do know the container name that it's trying to send traffic to within our task definition, because we only have one, right? And that would be, we named it client.
Okay.
Yeah, so that's what that'll be there. And then we know that container
I just want to go back. I did that really quickly. We went back to our container definition, and the one container we defined it is client. So that's where we're getting that value.
Yeah, perfect. And then we need to do the same thing for the port,
which was 9090.
Yep. And a techie thought asked, do we need a health check? And health checks are always great. We're actually going to let the load balancer deal with the health checking for our purposes. So that's where we'll see that. And that's actually what we're going to go do now. So that takes us on to the load balancer. We need to create that. It's like, oh, but you just said you need the target group on. We do, but the target group is something that that goes with a load balancer. And we'll see that here in just a second. So you can go ahead and make that next file for load balancers. Now, this is where we're going to kind of play the cooking show. Hey, here we've already gone and made it. And like I said at the beginning, load balancers are a pretty common topic. They're all over the place. It's something that's covered quite a bit. So instead, we're going to just sort of drop this in here and then go and take a look through it and just sort of explain what we've done.
So I want the AWS LB resource, right?
Yep, that's exactly the first one that we need. Yep. And so just looking through that, I believe all of those are exactly what we wanted, right? There is one problem here, is that we have not made a security group yet. So this is another rabbit hole we'll need to go down here afterwards.
Okay.
There we go.
So that would be
and
here. Yep.
Yep. So we can just maybe just comment it out so we know to go do it next.
Okay.
So that's the load balancer itself, but there's obviously two more things that we need. The next one's going to be our target group. And the target group, the way I like to think of it is it's like a pool that you tell an ECS service to put these different containers in so that the load balancer knows to send it to them. And if you are a part of that target group, you are a potential target to receive traffic. And so do you want to walk through these different things in here, Jenna?
Yeah, I mean, we're telling it which port we're targeting. We're using HTTP as our protocol. This is within the main VPC that we created. I'm not super familiar with this one.
I think it's just before it gets rid of it.
I believe.
I think that's just for when it. I think that's for when it deregisters it, when either we're getting rid of it or if it's goes unhealthy. Okay. Can't quite recall. I can look that up while you continue that explanation though.
Yep. We are targeting by IP. And then again, this is going to be where we set up that health check. There is a combination of how these work, all work together, and I'm probably not going to describe it exactly accurately. But ultimately what it's doing is, if for some reason the load balancer can't find the container on port 9090, then after a certain period of time, after a certain interval of time, then it's going to report it back as being unhealthy, and then that's when the service is going to restart it.
Yep. So for the deregistration delay, that's just how long in seconds that the load balancer is going to wait before it changes one of these targets from draining, so slowly letting traffic off, to being unused. And
Okay.
yeah. Now for that health check, the healthy, unhealthy threshold is the number of times it's going to check. And the timeout is just how long it's going to chill out and wait, right? Before it's like, oh, you're unhealthy. And then intervals just how often it's going to come back and do it. Yeah.
Okay. Yeah.
Cool. Nice.
Okay.
And so that brings us.
Yeah, and then I've fixed up the tags. Our sample code that we had some different values here, but so we're adding tags as well.
Yeah, perfect. All right, and then we have one more thing we need for this, and that's going to be the listener, right? Because we've set those things up, but we actually haven't told it to listen for anything yet.
So this is going to be the listener of the outside world is going to listen on port 80. And then it's going to target that target group that we just created.
Mm-hmm.
So
that's exactly it.
Just making sure we have everything correct here.
Yep.
So yeah, so this is where that's saying use this target group.
Yeah, perfect. So again, if you were, wanting to know like, oh, how did you all get to this? I would follow the load balancer console. It would tell you the things you need to be concerned about. You would reference the Terraform documentation and just put in those different required attributes. So, okay, so that takes us then to the security group for the load balancer, right? I know when I first got into infrastructure, because I came from a development background, and I thought the load balancer was some like ethereal like god that sat in your subnets and just did all the things. Turns out it's just practically another server that you launch into one of your subnets that accepts traffic and splits it back. So because of that, we have it in the public subnet. It needs to be reached. And because it is like that, we do need a firewall for it. We need to protect what is allowed in, what's allowed out. So we need a security group. So why don't we go ahead and make a file for our security groups? There we go. And quick bit on security groups is they're basically firewalls, right? They control access into and out of stuff.
I'm going to copy all three of the resources that we need all at once, and then we can walk through them.
Perfect.
Yeah, so the first thing we're going to do is create the security group resource itself. Again, I got to fix a couple things with variables. And then we're referencing, this is going to be a security group in the main VPC that we created.
Mm-hmm.
And then we're going to set up two rules. One is going to allow traffic on port 80. And then the other one is going to allow, so that's inbound traffic on port 80. And then the other one is going to allow outbound traffic. So that, and this is going to be, please correct me if I'm wrong here, but this would be like if we need to get out to the internet and like make updates to either our container or download packages, that type of thing.
Yep, that's exactly it. Yeah, we're saying that only stuff on 80 can come in, but if anything inside wants to go out, like Jenna said, to do stuff, we will allow it to go out. And since these are stateful, it's also going to allow the response to come back in as well. So,
okay.
Fun. So that's a security group. And again, we're not covering those too much, because if you're in the ops space or you've done anything, hopefully that this is, don't get too caught up into the syntax, right? Over complicating it. We're just saying, in front of this load balancer, only stuff on port 80 can come in, the end, right? So, all right. So back to our load balancer, where we are going to finish it off by referencing this security group, which is conveniently already done in a comment.
So I'm just going to update that. But again, like we're referencing, it's an array of security groups. So that's why we have the brackets. We're referencing the resource type and then the name that we gave it. And then in this case, we need the ID.
Yep, that is exactly it. And that should also show that if you wanted to put more security groups in there, you could. Okay, so now we get to go back up our dependency chain here back up to what we were originally doing, right? And that was defining a load balancer, which is right there. Yeah.
And so here we are adding that target group in. So we created that back in our load balancer. We created this target group. Did I get the right one?
Yep, that should be right.
Target group.
We need that. Yeah, there we go. That second label. Yeah, there we go. And that'll replace foo.
ALD targets.
Yeah. And that took me. Go ahead.
Okay.
I was just going to say that was something that when I was first getting to ECS, that it took me a bit to understand, which was like, from this, how the heck is this service in the load balancer really getting connected? Again, that target group is like a little pool. The service knows about it. Now it's going to go plop the containers in the pool. And the load balancer is going to look at that pool and send traffic to them. So that's how that works.
Yeah.
All right. So we got one more thing to do for our service here. And we're actually really close to the finish line just in general. And that is defining the network configuration block. So we want to head back over to those docs for the service real quick. And that should be, it's still in this same page. So yeah. So let's scroll down and see if we have an example of that anywhere. We do not. Okay, so if we scroll down into the argument reference, there we go, network configuration. We see it right under load balancer. Yeah, yep. This is actually a block. So to figure out everything that's needed for it, we need to scroll down some more, and there should be another section for it.
Oh, okay.
Yeah. And there it is, network configuration. And these are the three arguments we need to give to it. So why don't we go and fill those out? So the first one's, well, let's go ahead and define the nested block first. So there we go. How convenient. The first one's going to be subnets. And this is going to be what subnets are we going to put these containers in, right? And we probably want them in the private one, right? Because if we put them in the public one, it kind of defeats the purpose of load balancing off into a private one. So
we're going to reference. I just want to make sure I know how to find this in here. This public subnet that we created.
Ooh, we're going to do the private one.
Oh, yeah. That's what I said.
Yeah.
Private.
And an example of the exact.
This is why we have pair programming.
I think you've got the syntax down, right?
Now, I guess I could go look at.
Yeah,
it doesn't look like I have ID or anything in there, right?
Yeah, what we need is the ID of these subnets. So we want this to be a list of those subnets. And we actually have an example of it. If we go to the load balancer, back over to the load balancer file real quick, we see that for subnets, the splat syntax is how we say, hey, here's a list of the IDs for the public subnets. So we're going to just do the same thing here, except for the private ones instead of the public ones.
Yep.
Perfect.
So the splat is getting all of them that are, let me go back here, because we created multiples.
Yep.
So we want all of them. Okay. That makes sense.
So that's what that's going to do. And next thing is just assign public IP, which I believe is just another. And we just want this to be false. That's pretty simple, right? And then finally, we have we've got one more thing to do, and that is security groups, right? And this is where we're going to have to take another detour to go and create a security group here. So back to our security groups file. And first up, what is the security group for? Well, it's going to be the firewall. In essence, it sits in front of those different containers so that we have some more control there as well. And once again, instead of walking through all of it, we're going to drop it in because they kind of all look the same. So
just making sure I'm getting the right ones.
Yep.
So we've got, this is for security groups for our client service. Again, I'm going to have to fix a couple things here.
Yep.
part of our VPC.
Yep, I think those names look right.
That all looks good. So we've got our inbound allowing on port 9090.
Mm-hmm.
And
that one's a little tricky. That one is just saying if another, this is basically saying if you have this security group, you can also access me. So if we have, McDonald's service and a Wendy's service, I don't know how we've gotten to that, and each of them have this security group, because they both have that security group, they can both access each other. So that's all that one's saying there.
Okay.
Yeah. And then the last one's just the allow outbound from anywhere. So if they need to reach out to get something, they can do so.
Okay.
Any thoughts on that security group?
Nope,
Jenna?
I think that makes sense.
All right.
So we have, I just want to make sure I'm understanding. We've got one for the client load balancer, and then now we have one for the service itself.
Yep, exactly. So now we go and we complete our destiny in the services file.
Services. Trying to remember where we were.
Specifying security groups.
Yeah.
Yep, there we go.
Oh my gosh. I'm so embarrassed. Like this is not like my IDE should be set up better than this.
Jenna's like, I swear I'm not
really
an 8 spaces person.
I'm just like that. I'm not a real coder if I don't have it set up right.
So this is going to be a list, just like the load balancer had a list of them. So just open that up, and pretty much the same syntax. The resource type, which was AWS security group, I think. Yeah. And then the identifier we gave it, I don't remember already, even though we just looked at it. Yeah, ECS client service. And then we need the, what do we need for that? I believe we need the,
would it be the same as
I think it's the ID.
We did ID in the load balancer.
Yes, yes, I think, yes, we need the ID. That's what we need.
Okay.
So there we go. And so Jeffrey here is asking where the earlier recording is. So we posted it in the chat. I don't know. I know why you're not seeing it. You're not seeing it because we can't post direct to the LinkedIn chat. So the easiest way to get to it is just to go to HashiCorp's YouTube channel, and it's one of the episodes. It's just right there. It's on the front page. So you should be able to find it just fine. Okay, so that is what we need there. And unless I am mistaken, we are done. We've got everything that we need to do.
Yeah, I mean.
Yeah. Yep, that's it. So we've defined the task definition saying, hey, this is the containers we want. The service to say, hey, go make these containers. And then the load balancer to say, send traffic to my containers.
Okay.
Now we get to see how badly we've messed up by running Terraform plan, right?
Right. Okay, yeah. So let me get back to my terminal. And I mean, I probably mistyped something somewhere. So
I mean, it's not a day in DevOps if you haven't fallen to the dark forces of an extra semicolon or curly brace, right?
Or the word connections randomly getting shoved in there.
Oh, look, we made it through the first part. Look at this.
Okay.
Everything is there. Nice. So we're adding all sorts of new things.
Got these little pluses here, and it's saying it's going to be created.
Nice. Okay.
Okay, so we have 12 that are added, 0 that are changed, and 0 destroyed.
Nice. So I guess we're ready to apply now. All right, and it's going to show that plan again. And it's going to go and refresh.
What that? Oh, yeah.
Go ahead.
I just was going to say, so now that we're going to let this run, I'm going to press, we reviewed the plan. I typed yes, so it's going to provision all the resources we just created. I'm going to actually go back and let's, we're coming up to the end, so I want to before we get too far to our wrap up and try out what we've done today, I just want to throw this QR code up here again. Like I mentioned earlier, or if you've just joined us, we very much value your feedback, any constructive criticism on how we could run this show better, or if you want to see different topics or different people, or hopefully not different people.
That'd be awkward.
But any sort of feedback on the show itself, the topics that we're talking about, or even related to the products and services that we're showing off, we have the ability to take that feedback and bring that back to our teams and help shape the products and services for you to make sure that you're getting what you need and your problems are being solved. I'm just gonna look. It looks like we do still have, if you haven't filled out the survey yet, we do still have some credits that are remaining. So
Nice.
A little bit of incentive. Do you want to talk about I don't know if the other giveaway is over or not, but
yeah, well, I wanted to give that one more plug here. So let me go ahead and share my beautiful little slide here. Let me put it up here. And so again, we're doing 10 $50 giveaways to our HashiCorp store. To enter into this, you just need to make a post on Twitter or LinkedIn, tag myself, Jenna, and use the HashiCorp Live hashtag, and just tell us about something you learned during the stream that you thought was interesting or that was helpful. And if you don't have, maybe you already know all that stuff, maybe you got a new idea, tell us about that too. And after we see all of those, 10 people will get picked and you'll receive a $50 gift code. Now to make sure that I can contact you, that's why I'm having you tag us on Twitter so I can actually reach out to you in a direct message to give you that gift code. Yeah. And there's a number of things that you can get with that. So I'll just go ahead and pull it up. Just again, we've got shirts, bandanas, hoodies. I've got the Pride shirt that I'm wearing right here on. So a lot of cool stuff just to add to your swag collection. All right, I'll put that graphic back up. How's our Terraform apply looking?
Let's take a look.
It
looks like we've successfully created all the things.
Oh my gosh, really? All right, well, let's go back to your screen here. Oh, look at this. So it's successful. So let's see if it's successful. So let's go to our EC2 console here so we can get the load balancers DNS. And we'll just find load balancers somewhere down yonder. Here we go. And then that DNS name. Yeah, have fun copying that. Man, that is a long one.
Yeah, it is. Yeah. So we just hit it in our browser?
Yep.
So, okay, before we do this, what are we expecting to see?
We are expecting to see that message come back along with some other headers and different things.
Okay. So, and that message was something like, I just want to make sure I remember. That message that we created was in here in the, it's going to be hello from client.
Yep.
So again, this is a very dumb service at the moment. We're using that fake service and as a way of just kind of keeping it simple, not having to show all the ins and outs of an actual service that we're hosting. So all it's doing is returning that. And like you mentioned, a few extra.
Oh, it worked.
So
nice.
This.
Hey.
There's the body of our response.
Oh yeah. Will you add /UI to the end of that URL?
Yes.
Because fake service actually comes with a UI built into it. So if we go to that, we'll see, hey, there we go. It's all up and running. I can't believe it worked on the first try. Like I literally thought that it wasn't going to, because I'm just so used to these demos, you know. being
I mean, we did have a few typos, so it's all good.
Yeah. All right. So one more thing I wanted to show. This is going to just take a hot second here. And it's, outputs. It's what if I want to see stuff output from Terraform instead of having to say, go to the console. And for right now, it's just a convenience thing, but later it'll be if you want to pass values between Terraform modules.
Right.
So just I'm going to throw a doc over to you, Jenna.
Okay.
And let me find you so I can give you that out. And this is just another one of those core things. There's like the resources, there's the variables, and then there's the outputs. So we just throw that in there. And yes, a techie thought. Thank you. Jenna's doing an awesome job of typing here on the spot. Yeah. So output values, they're just when a resource is done, we can output, not done, but we can output values from them. Much like how we can reference attributes in between resources. What if we just want to know those values and see them, right? Well, this is what we can use to do that. So instead of going through the whole doc, I'm going to put this in here so you can reference it at your convenience. But why don't we head back over to your code editor and make a new file called outputs.tf. And why is it called that? You can call it whatever you want. We could call that Jenna.tf we want, but we're just going to make it simpler here. And what we're going to do is just go ahead and type output, and we should have an autocomplete thing pop up for us. There we go. And we're going to name the output. For this first one, I just want the DNS for the client application load balancer so we can see that in our terminal every time and don't have to go fish for it. So
I didn't really have to do like the hunt and peck through the console. Now I'll be able to actually see this in my terminal.
Yep, exactly. And so the next thing we want to do is the value. This is what goes here is exactly what you would use. Well, we should get rid of the double quotes, but what you would put here is exactly what you would use if you were referencing this between resources. So we referenced the load balancer in our services file, right? So let's go take a look at that real quick. Here we go. Well, I guess we kind of referenced it. We referenced the target group. Go to the load balancers file itself. This is where we reference the load balancer. Yeah, if we go down to the listener, I think, all the way there. There we go. We see in that load balancer ARN, so the line 36, we see that we're referencing the ARN. So let's go and copy that because this is going to kind of serve as 2/3 of the way there. But we don't want the ARN. We want the DNS name. Now, there actually is an attribute that you can read off, an attribute you can read off the application load balancer to get the DNS name. And I think it's just called DNS name. DNS_name. Yeah. Yeah. I mean, I'm positive that's it. We can go look at the docs if you want, but that is absolutely it.
Yep. I think.
And then the only other thing is description, and that's just a description. It's just a string of just saying what it is. Yep. And again, we're just using this for convenience, but when we start talking about modules, that's when outputs really get useful because that's how you pass them between different modules of Terraform code. But that's all we needed to do there. Now we're just going to run Terraform apply again. Nothing's going to change. It's just going to output that at the end. So nice and convenient. Of course, the scary part is when you do an apply and it's like, oh, hey, there's all this other stuff we're going to change too. And it's like, what? When did you figure that out? There we go. Okay. So something to touch on here is if we scroll up, it's saying, hey, we're changing some stuff. And it's like, whoa, I didn't do any of that. Where is this coming from? Well, what this is coming from is after resources have been made up on AWS, they're going to get things. They're going to get information added to them that Terraform didn't know. So when we do this the second time, sometimes it'll say, okay, well, we know these things now, and we're going to go ahead and add it to our local state to keep track of it. But nothing is actually changing. Okay. Nothing's actually going to be like recreated or destroyed. But always double check just in case.
Yep. Oh, as an example, like this one here, we didn't know the actual ID of the security group until it was created. So now it's just updating. I think you called it the state, right?
Mm-hmm. Yeah, and we'll talk about the state file later on. Okay. But there we go. And we just do, or don't type yep, type yes, but. And there we go. We see the client ALB DNS just right there for us so that we can just grab that whenever we want to.
Cool. Another way that these outputs can be used, you can redirect them into a text file and then use them as import into maybe tests that you have. So if you're asserting against specific resources or specific configuration about a group of resources, you can make sure that your tests are dynamic rather than hard coding all these IDs and various other data that you need for testing.
Yeah, that's a perfect example. And hopefully we'll get to touch on that. That is, yes, that's like, yeah, your Terraform game just leveled up hardcore, Jenna.
Yep.
You're a paladin now. How does it feel?
Yes, yeah, this has been fun. I've done a lot of what we've done, I've done in other infrastructure as code tools and through the AWS console. And so a lot of this, by doing this in another language, like it's really reinforcing what I had learned previously, but it's also reinforcing more about the specific services too. So that's just kind of how I learned. So that's exciting for me.
Same for me, getting another refresher on ECS, getting your input on it, Darko's input on it, everyone else who has helped. It's been really, really nice. So we are at the end. Why don't we do a recap and a summary real quick?
Yeah. So we started by, I'm actually going to go back to the code really quick, just to refresh my memory. So we started by creating that cluster, the very, very short resource that is going to group our different containers. And then we created the task definition, which talks about that's the blueprint for our application. So in this case, right now we just have one container definition. In the future, we could add different containers here. And then we started working on the service, which helps us manage the life cycle of the container. So if for some reason it shuts down or goes away, this will help make sure that it stays around or that it gets replaced. Then we configured our load balancer along with our security groups to make sure that our container actually has incoming access from the internet so that we can access it through that DNS name, and then again outbound access to the internet in case we need to get any updates or packages, that type of thing.
Yep.
And then last, we just talked about the output. So again, rather than me having to go into the AWS console to figure out what the DNS name that is being used for the load balancer, we actually can create that output directly so that when we apply this in the terminal, it gets output right there and I can just copy paste it and put it in my browser.
Perfect. That I have nothing to add.
Sorry, I didn't mean to steal all of it.
No, you didn't steal anything. You did it amazingly. All right. So since we're here at the end, why don't we do the survey giveaway recap one more time?
We do. I want to make sure we don't forget one more thing. We almost forgot it last time. Do you remember what that is?
Does it rhyme with destroy?
It does, actually. We do want you to take the survey. And again, the survey is so that we can make sure that we get better. Our products and services get better. Any constructive feedback is super, super helpful for us. This is how you can get there. There might be some credit codes left. If not, I hope that you join us at our next episode because we'll do the same thing again. But before we leave, we need to actually, we can't forget to destroy our resources. I don't want to leave them running because again, unless this is a production workload, we don't want to incur any costs here. So if you're doing this, make sure that you are if you're doing this alongside of us, make sure that you are destroying in between each session that we host.
Mm-hmm. So while you run that, why don't I'll go ahead and do the giveaway recap one more time.
Okay.
That sound good?
Yep.
All right. Okay. So one more time on the giveaway. We are giving away 10 $50 gift codes, yes, to the HashiCorp store. All you got to do is just make a post for us on Twitter or LinkedIn, tag myself, Jenna, and the hashtag HashiCorp Live, and just tell us about something you learned from the stream, or if maybe you're a veteran and you've been on the front lines with this stuff, maybe some cool new idea that came of it. And what we're going to do is we're going to aggregate.
Sorry to interrupt. Something I'd like to hear is like what if you've been doing this for a while and maybe some of this is not new to you, but like there are a lot of people on the stream where this is new to them. So if you have experience to share that would be interesting, please let us know that too. Like what have you learned from doing this in production at scale?
Yeah, that would be excellent. Yeah. And what we're going to do is we're going to collect those, and 10 posters are going to be selected to win that $50 gift code. Make sure that on LinkedIn or Twitter that I can contact you so that I can send you that gift code so that you can get it. And we've got all sorts of swag. We got shirts, hoodies, laptop cases, backpacks, mugs. We've even got bandanas and socks. So there's a lot of cool stuff there. Okay, so back to Jenna's screen, and let's see how destroy is going here.
It's still destroying. I know some of these resources take a little bit of time.
Yeah.
But it's going.
It's always such an odd feeling when it's like, I did all this work, now I'm gonna just burn it all down in like a couple seconds.
But okay, so it's all destroyed. But again, like it's our work is in the code, it's not in the resources. So I just did a git status here. I'm not going to do this while we're on air here. I'm going to do this outside, but I'm going to commit all this stuff and push it up to our repo. Let's get a link. I have a link somewhere.
I've got it showing on our on the stream right now.
And so that'll be updated. I'll do that today sometime. And each episode is a specific branch, and then everything will eventually the full thing will be merged into main, so that you've got the full thing, but you can also go at each specific episode if you'd like.
Yep. And similarly, we will have the full broadcast that's being recorded up on YouTube. We'll have chapter markers for every one of the sections so that you can watch it at your convenience, come back to it later if you need to watch it in bits, and along with all of the links that we've talked about here, so you'll be able to learn at your own pace in... I've ran out of words.
Yeah.
I've run out of words. All right.
All right. I think that's it.
That is it. Next time, 2 weeks from now.
Yep. So we're trying to be on the every other week plan. So I think that puts us on, oh my gosh, I had it. What date? That would put us on March 17th.
March 17th. So save the date. And we will continue our journey into finishing out this microservices architecture sans service mesh before we step into the next section.
All right. Thank you all for joining us. We appreciate your time today.
Thank you so much. Until next time.
Bye-bye.
Bye.